If you work with geospatial data, you know the problem. Millions of intersecting paths and nodes create an unreadable web of glowing noise. GeoVact is designed specifically to ingest that spatial clutter and organize it into categorized, readable analytical maps. Today, we will execute a complete network analysis, taking a dataset from the initial file upload all the way through to a customized output layer. Mastering this specific workflow allows you to strip away the visual static and locate the patterns hidden inside the data. This is the primary GeoNet workspace. To begin, locate the click-to-upload.zip drop zone in the center of the screen. You will need a package dataset ready on your local machine. You can click the drop zone to browse directories or drag your file directly onto the interface. Do not extract or unzip your data folder prior to this step. GeoNet requires the package.zip format. Uploading the intact archive ensures the engine reads your complex network geometry as a single, cohesive structure, rather than a fractured list of standalone files. Once dropped, the interface explicitly displays your staged file name, confirming the package is loaded. Feeding the application unextracted archives is the baseline step to prevent spatial errors downstream. With the data loaded, move over to the Parameters module. This is where we assign the mathematical rules that will define your map. Under Classification Settings, you have 3 statistical models to choose from: natural breaks, also known as Jenks, equal count or quantile, and equal interval. The Jenks algorithm groups data by seeking out mathematical gaps, creating distinct categories where values naturally cluster. Now watch equal count. The system ignores natural gaps, instead forcing an exact equal number of data points into each bucket. Next to model selection is a class count dropdown. This parameter allows you to split your data into anywhere from 1 to 20 separate classes. Cautionary: avoid selecting the maximum 20 classes for standard datasets. Creating that many categories generates an overwhelming amount of visual noise. Instead, set your class count between 5 and 7. This ensures a clear, readable narrative. Selecting the correct statistical model and class count determines how your data is distributed, establishing the internal logic of the visualization before any styling is applied. Scroll to the Output Layer section. This step translates statistical classes into a tangible visual design. First, set your opacity to exactly 80%, and set your line width to 2 pixels. Leaving the opacity at 100% will entirely obscure your underlying base maps, stripping away the geographic context your network sits on top of. This split-screen image shows how your color ramp affects visual hierarchy. By checking the Invert box, you flip the color scale entirely. This lets you choose whether your lowest values or highest values draw the viewer's eye. Once your colors are set, click Run Analysis. Do not refresh the page while the system is working. A running analysis prompt will take over the screen. The system is now locking in your parameters and processing the layers. Applying these specific settings ensures your network layers remain legible without washing out the critical geographic details on your base map. When the processing completes, your fully rendered analytical map will populate the main workspace. This close-up view shows the map's layer panel. Notice your newly generated result is checked, active, and sitting at the top of your layer stack. We started with a raw.zip archive, applied Jenks statistical processing to group the numbers naturally, and styled the output with an 80% opacity. Your map is ready to present. For your next pass, try switching your model to quantile or invert the color scale. You will quickly see how adjusting those parameters pulls an entirely different visual story from the exact same dataset.